Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to have an idea about smart materials. Introduction to smart materials, its properties or characteristics, and then some basic components that are related to smart materials and the various categories of smart materials. So, let us start with the introduction part for smart materials. Smart materials are the materials which will behave intelligently or they respond smartly basing on the environment. That means output it is taken from the surroundings or the environment. Accordingly, it will change its behavior in its properties. That is what we call it as a smart material. So, these are defined as the materials which are also known as intelligent or responsive materials, which are defined as smart materials, those in which properties can be significantly changed in a controlled fashion by external stimuli. External stimuli means from surroundings it is able to take temperature, or we can say if mechanical stress is applied or moisture it is able to absorb, and some external magnetic field is applied or some external electric field is applied on that material, or even if light radiation it is going to fall on that material, then accordingly that smart material will respond. So, such kind of materials are called smart materials. So, few examples for external stimuli will include stress, moisture, electric field, magnetic field, light, temperature, pH. Even in the case of pH variation also, it is able to consider that pH variation from the surroundings, and accordingly it will convert its properties so that it will behave like a responsive, or we can say smart material. And chemical or biological components. So, if that material it is treated with a chemical component or any biological component like microorganisms, then accordingly it will change its behavior. So, such kind of materials are what we call it as intelligent or responsive, or simply we will call them as smart materials. So, smart materials are defined as those in which properties can be significantly changed in a controlled fashion by applying external stimuli like stress, moisture, electric or magnetic field, light, temperature, pH, chemical or biological components. So, smart materials and normal materials. So, what makes the difference between normal materials and traditional materials and smart materials means materials which can think on their own, and they will have a mental alertness, quick perception, speedy activity, effectiveness, spirited liveliness, and then intelligence. So, whereas if you notice the case of smart materials, they are able to respond to a change, and these are able to receive the information, that is sensing the problem. They are able to identify the problem or able to sense the problem, that is from its surroundings or we can say environment, and able to analyze and decide. That means processing the information. This step will include processing the information. Step 1, it is able to receive the information, that is sensing the problem, able to identify the problem from the surroundings, and then it is able to process that information, that is analyzing and deciding, and then actual processing will take place, and accordingly it will respond as output, that is able to act on the decision, that is called actual processing. So, if you notice same kind of thing with the normal or traditional materials, so what they are able to do is they are able to think on their own, and they will have these kind of abilities: mental alertness, quick perception, speedy activity, and then effectiveness, spirited liveliness, and then intelligence. So, directly I am switching to properties of smart materials. So, these are smart materials, or we can call them as intelligent materials or responsive materials. These are either passive or active. So, what do you mean by active and what do you mean by this passive kind of smart materials? Let us see. So, active smart materials are those materials which have intrinsic ability to transduce energy, whereas passive do not. So, if the smart materials are active in nature, that means they are having a property called activeness, then what they will do, they will have an ability which is intrinsic in nature to transduce the energy, whereas this passive type of smart materials are unable to do such kind of things. Example for this kind of active smart materials include piezoelectric materials, which are active smart materials, while fiber optics, if you notice, which will come across in physics part, the fiber optic particles are passive in nature. So, piezoelectric materials means when we apply some amount of mechanical stress, that means if we are applying some kind of force or pressure on that material, then it is able to generate voltage or we can say electricity. Such kind of materials are called piezoelectric materials. So they will come under active smart materials. While this kind of thing will not we can notice in the case of passive materials. And coming to the next thing, generally sensors and actuators also will come across with smart materials. The sensors and actuators are two different type of materials which are having a fundamental functions of smart structures for sensing and controlling the purposes. So let us know about the basic components of smart materials. So as I told you, sensors and actuators, two different types will be there. So this is nothing but a major or we can say basic component of any smart material. So what sensors will do? Sensors are a kind of smart materials, or sensor is a kind of device that is used for conversion of physical events or characteristics into electrical signals. That means it is able to sense or identify any physical properties or characteristics from the surroundings, and it will release that entire properties into an electrical signal. So this is a hardware device. This is a hardware device that takes input from the environment and gives to the system. For the case of smart materials, we have to consider two basic components. One is system and the one is the environment. System, it is nothing but the material itself, and the environment is nothing but a kind of surroundings where that system it is placed. If it is for the case of a sensor, what it is able to do? It is a kind of hardware device which is able to take the input from the environment. Say for example, temperature or some kind of sensors. Nowadays we are going to make use in under the heading modern farming. So those are type of sensors which are able to identify moisture content around a plant. So that means from the surroundings or we can say from the environment, it is able to absorb the moisture content that is present around the roots of the plant in the soil. So that accordingly it is able to release the signal in the system, signal to the system. So this is a type of hardware device that takes input from the environment and gives to the system by the conversion. Example, best example, it is one I told you just now, that is moisture sensing sensor, which is used for identifying the moisture content that is present around the roots of a plant in the soil. So it is able to take that moisture levels, basing on that one, that is temperature, it is able to release its output into the system, whether it is high level or it is low level, whether it needs more irrigation or not, that we can reveal using that moisture level sensor. And coming to another example, a thermometer. Thermometer, it is meant for noting down the temperature, right? So it is also an example. A thermometer takes the temperature as a physical property or characteristics from the surroundings, and it is able to convert that one into a signal. So it is able to convert that one into an electrical signal for the system. So from the surroundings it is able to take, and it is able to release that one in the form of a signal to the system. So if you reverse that kind of a thing, that is what we call it as actuator. So an actuator is a device that converts the electrical signals into physical properties or characteristics. So that means it is able to take the input from the system and gives the output to the environment. So it is able to take the input from the system and it is able to convert that input that is taken from the system into output and release into the environment. Say for example, motors and heaters are some of commonly used actuators. So I am directly switching out to the different categories of smart materials, or we can say examples, best examples for smart materials of various categories. In today's class we are going to deal about. So first one, it is piezoelectric materials. Piezoelectric materials. So what are piezoelectric materials? Means the materials that are able to produce a voltage when a mechanical stress it is applied on the material. If some mechanical stress it is applied on the material, then in general what it is able to do, it is able to convert that stress into a kind of electricity, or we can say voltage. So such kind of materials are called piezoelectric materials. Piezoelectric materials. Since this effect also applies in the reverse manner, if voltage it is applied on the sample, if voltage it is applied across the sample, it is able to produce a stress within the sample. So suitably designed structures made from these materials can therefore be made that can bend, expand or contract when a voltage it is applied. So that means it is two-way. Materials which are able to generate voltage when they were subjected to some mechanical stress. That means we are applying some amount of pressure, or if you are bending bending that material. So if it is that material it is subjected to some amount of stress, then it is able to generate voltage, and that reversing also will take place. That means if voltage it is applied on the sample or such kind of a material, then it is able to convert that one into mechanical stress. That means it involves in either bending or expansion or contraction when voltage it is supplied. So example for this type of materials are quartz, and then alloys of barium titanium, that is in the form of oxide form. So some are examples for piezoelectric materials. So this piezoelectric effect is able to describe the relationship between mechanical stress and electrical voltage in the case of solids. Applications. If you notice this lighter, which generally we use for domestic purpose in our daily life, in lighters or portable sparkers, when piezo it is applied suddenly, that is strong pressure it is applied, which is able to produce voltage. That spark then ignites that gas that is released from the cylinder. So this is applicative part related to piezoelectric materials. Coming to the second category of smart materials, these are called shape memory alloys. Shape memory alloys. So name itself it is revealing that they are able to keep it in mind that their original shape of that alloys will be memorized, so that it will behave accordingly with the changes that were taking place in the surroundings. So let us see what are shape memory alloys, and its short form it is SMA. Shape memory alloys are a unique class of metal alloys that can recover apparent permanent strains when they are heated over a certain temperature. If any material is subjected to heating process with certain amount of temperature, then these will behave accordingly. That means they are able to bring their change in their original shape. That means on heating they will convert into another shape, on cooling they will come back to their original form. Such kind of materials are called, or smart materials are called, shape memory alloys. That's why these SMAs are defined as a unique class of metallic alloys that can recover apparent permanent strains when they are heated above a certain temperature. So we can notice a phase transformation when this kind of a process is going to take place. That means when they are subjected to heating process by applying some amount of temperature, we can notice a phase transformation that takes or that occurs or that takes place between these two phases upon heating, or we can say cooling, is the basis for this unique properties of smart memory alloys. That means these smart memory alloys, they involve in phase transformation during cooling and heating process. So that's why we will call it as a unique property, and such type of materials are named as shape memory alloys. So if you notice, one example I have considered, that is austenite. At high temperature it is named as austenite, and at low temperature it is named as martensite. So these are the two phases of this austenite shape memory alloy. That means it can be twinned as well as it can be detwinned, basing on the subjecting to temperature. That means when it is heated and then after cooling. So it is involving in different phase transformations. Basing on that one, we will give different naming to that memory alloys. These shape memory alloys, SMA, or alloy means it is nothing but a combination of various metals. Sometimes this kind of smart materials can be polymers also. That means shape memory smart materials, generally we will talk about this shape memory smart materials may be of two categories. One is shape memory alloy, other one is shape memory polymers. So these two will come under one heading, that is called shape memory smart materials. So in the previous example we have considered shape memory alloys. Now we are going to discuss about shape memory alloys. Both are there in your syllabus. Let us go one by one. Shape memory alloys and shape memory polymers are temperature responsive materials. That means whenever such type of smart material it is subjected to heating by supplying some amount of temperature, both are able to involve in giving or responding. Such kind of materials are called shape memory smart materials, where deformation can be induced and recovered through temperature changes. When it is heated, it is able to involve in deformation, and after cooling it will come back to its original form. So that is, they are able to memorize their shape, their original shape, when subjecting to heating and then cooling. SMAs are the materials which can revert back to their original shape and size on cooling by undergoing phase transformation. How this is able to happen in the case of alloys and even polymers also means they usually they involve in phase transformation. That is, during heating and cooling process, they involve in some phase transformations. Accordingly, they will respond in their output exhibition. Examples: nickel titanium alloy that remembers its original shape. During heating process, it involves in deformation, and its original shape it is able to keep it in mind, and on cooling it will come back to its original form. On cooling, it is forged shape. By heating, it returns back to their deformed shape. Another examples will include alloys of nickel, manganese and gallium, and then iron, palladium and terephenol D. So few are examples for smart memory alloys. So if you notice, in the earlier case also we discussed the same thing, alloy of nickel. Same example here we are going to consider. So that is martensite. Actually it is having this kind of shape and size when subjected to heating by supplying some amount of temperature. So it is able to convert into austenite. A proper alignment we can notice in the alloy solid form. So and after cooling, it will involve in change in its shape. That is also known as martensite while cooling. So after complete cooling it is done, again it will come back to its original form. That is original shape, it is able to keep it in its mind, or it is able to remind that shape. Same thing here also, it is explained in the form of a graph. So with respect to temperature changes, what it is able to involve in a transformation, that is deformation initially, and then coming back to its original form. So and then another category of smart materials are magnetostrictive materials. So this is third category. In today's session we are going to learn about different categories of smart materials as I explained earlier. So two we have completed. One is piezoelectric materials. Another example or another category, it is shape memory smart materials. Again in that we have two different types, shape memory alloys and shape memory polymers. And then coming to the third category, that is magnetostrictive materials. Magnetostriction is a kind of a property of ferromagnetic materials that are able to cause them to change their shape, or we can say dimensions, during the process of magnetization. That means whenever it is subjected to some amount of magnetic field, what kind of changes will come across with that material with respect to the shape, or we can say dimensions. So such kind of a property is what we call it as magnetostriction, and materials which are able to exhibit such kind of a property are called magnetostrictive materials. So examples will include iron, cobalt, terephenol D. So some are examples for magnetostrictive materials which are used in transducers, sonar, sound bug. So all these things we will come across with this type of smart materials. And then actuators and sensors. Another category, it is number 4, it is actuators and sensors. So these generally include magnetostrictive materials or transducers, which we call them as, which are able to convert, the materials which are able to convert magnetic energy into mechanical energy. That means if you supply magnetic field on that material, then it is able to convert that energy into the form of mechanical form. So such kind of energy converters, or simply we will call them as transducers, those are named to be magnetostrictive transducers. So these will come under the category of actuators and sensors. And let us go with the next category, that is chromic materials. Chroma means color. So these are of different kind of things. That material can be subjected to light, temperature, electric field, even pH, anything we can apply on that material. That means external stimuli can be anything. So accordingly it is able to change its color. Say for example, generally for kids, nowadays we are using some kind of polymer based bathtubs, and then feeding spoons. So which are able to tell us the temperature of that food, or we can say solid material, solid food which we are going to feed that baby, or a temperature of hot water which we use for bathing purpose for kids. So in that bathtubs, they means they include this kind of chromic materials. So that say for example, if you take the feeding spoon, the temperature itself it is able to identify. That means that the spoon itself is made up of this chromic type of materials. So as and when that spoon which is made up of that chromic material is subjected to temperature, that means if you dip that spoon in food which is at a very hot condition, then it is able to sense the temperature. So accordingly it is able to change that color of that material. Say for example, it is made up of biodegradable polymer. If it is kept in that food material which is at hot condition, then immediately it is able to change its color. So such kind of materials are called chromic materials. The same thing with bathtubs also. So after filling that bathtub with hot water, it is that material of that bathtub is able to sense the temperature of that water. If it is high, then it is immediately able to change the color of that tub. So such kind of materials are called chromic materials. So it's not only a kind of temperature or any kind of external stimuli we can use, like light irradiation on that material, and then subjecting that material to some amount of electric field or magnetic field. So basing on this type, chromic materials will be developed. So these are the materials, they have excellent properties to change their color when subjected to external stimuli, or we will call it as impetus. For example, temperature, two examples just now we discussed. And then with respect to light also, like sunglasses, or we can say eye spectacles or some kind of a thing, whenever when that light irradiation takes place on that glasses of that glassware, then immediately it is able to change the color of that lens. And then electric field, if that material it is subjected to some amount of electric field, it is able to change its color. So examples few here mentioned, a variety of dyes, pigments, even in some kind of schools, kindergarten schools like that. So generally the way they teach, it will be a different style for kindergarten students. So in that kind of schools, what they will use is, they will use different types of dyes. Basing on the sunlight absorption, they are able to change their color. So likewise we use for traffic signals and all. I mean on roads, generally night time we will have that fluorescent caution hoardings, and then some kind of paints we use on the roads, markings for that one. Night time they are able to glow. So all these things are nothing but smart materials which come under chromic materials. If light gets fall on that paint, when we are going to drive a car or any vehicle on the road, so if light falls on that paint, it will glow immediately. That means it is able to show us the direction or any hoarding or any obstacle if it is there on the road. So likewise, these are few examples for chromic materials. In that light it is to be irradiated on the object or material. So a variety of dyes, pigments, oxides, organic molecules, even conjugated conducting polymers are also best examples for exhibiting this change in the color basing on the external stimuli, which come under examples for chromic materials. And the next category, it is of electrostatic materials. So that name itself, it is able to represent or tell us that whenever that material it is subjected to electric field, that means in the presence of electric field, these materials are able to experience a strain, that is mechanical change will take place, which is proportional to the strength of electric field. That means if you supply some electrical field to a material, then those materials are able to experience a strain, or we will call it as mechanical change, which is always directly proportional to the how much amount of electric field that we have used, that is its strength. Example, lead lanthanum zirconate titanate, PLZT, it is a kind of alloy. Lead magnesium neobate, that is PMN shortcut. And then next category, it is of thermoelectric materials. Another example for smart materials, it is thermoelectric materials. So these are the materials when subjected to any temperature difference, system temperature as well as surroundings or environment temperature it is able to sense. So basing on temperature variation or temperature difference, they are able to generate or produce a voltage. They are able to generate voltage, and other reversing also will take place. That means when these materials are subjected to any voltage difference, that means voltage difference in the sense system and surroundings, that material voltage and then surroundings voltage if it is varying, then we can have a difference between the two voltages. Then it is able to bring a change or response in the case of its temperature, system temperature. So these kind of materials are called thermoelectric materials. So here both were mentioned in its name. That's why it is named like thermoelectric material. And the next example for smart materials, it is rheological materials. Rheological materials. These are able to change the state instantly through the application of electric or magnetic field. So whenever these kind of materials, they are able to respond, that is change in its state, that is instantly through the application of electric or magnetic field. If you supply some amount of electric or magnetic field, then immediately these kind of materials are able to show a change in their physical state. Example, silicates and some kind of food additives. At room temperature, they will be like solids. After adding that food additive to that food that was on a boiling process or cooking process, it will convert into a liquid so that it is able to impart some kind of color. So such kind of, that means when it is subjected to some amount of temperature I am talking about, in a similar manner when applied to electric field or magnetic field or any other type of field, then immediately it is able to change its physical state. And then pH sensitive materials. So these are a kind of smart materials which are having a properties to change their color, and there will be a change in the acidity of the liquid. So these are sensitive towards pH. These kind of smart materials will respond basing on the pH value. So in the surroundings, if these are able to notice a change in the pH value, that means pH should be neutral, means pH it is equal to 7. Less than 7 means that solution, or we can say liquid that is present in the surroundings, will have acidic nature. If it is greater than 7, then solutions of the liquids that were present in the surroundings will have basic nature. If it is equal to 7, then they will have neutral behavior. So accordingly, these materials are able to behave. So basing on the pH variations that for the liquids or solutions that were present in the surroundings, these are able to change their properties, that is color, to change their color. Like pH strips we will use in organic chemistry lab, it is also an example. These kind of smart materials can be used to indicate the corrosion by mixing it with paint. So this is most important application related to pH sensitive materials. So what happens when it is added as an ingredient to the paint? So when this paint it is used on any metallic surface for protecting that one from corrosion. So if any acid rain falls on its surface, so then immediately it is able to change the color, so that we can protect that construction in long run. So these are the examples. And the next one, it is thermoresponsive materials. These are nothing but as I told you, shape memory smart materials. These will come under shape memory polymers. Thermoresponsive polymers. These polymers which exhibit drastic and discontinuous changes in their physical properties when they were subjected to some amount of temperature. So with respect to temperature supply on that material, these are able to change or bring a discontinuous and drastic changes in their physical properties. So such kind of polymers are called thermoresponsive polymers. So these are contrast to temperature sensitive materials which change their properties continuously with the environmental conditions. So some type of smart materials will be there. So these are nothing but temperature sensitive kind of materials. So those are different from thermoresponsive polymers. That means these are able to change their, bring the drastic changes in their physical properties continuously with environmental conditions. Usually the temperature responsive term is concerned with the solubility property in a given solvent but not only limited to solubility. So based on the miscibility gap of the polymers in the phase diagram, polymers can have their lower critical solution temperature, that is represented like LCST, or upper critical solution temperature, UCST. So they involve in phase transformation. The polymers which are miscible, that means completely soluble, and we can notice homogeneity. That is what we call it as single phase. Say for example, for 1 tumbler of water, if you add sugar and mix it, then what we are able to notice? Oneness, that is homogeneity we are able to notice. That is called miscibility. That means water is able to dissolve sugar that is added in it. That is called miscibility. That's why we can call that one as single phase. Homogeneity we can represent like single phase. That entire sugar dissolved in water is having single phase. Single phase means miscibility they are having. That means 2 I have added, but homogeneity we noticed, so that single phase we can notice. The polymers which are miscible are named as single phase below the phase transition temperature, and it will exist in 2 different phases above the phase transition temperature. So at lower CST it will exist in single phase, and in upper CST it is having immiscibility. It means it does not dissolve. That polymer materials are immiscible in nature. That's why they will exist in 2 different phases. So that is what here it is mentioned. Single phase region will be, this is the lower CST. Below this region single phase it is existing. Above this LCST, lower CST temperature, 2 phases are going to exist. That is called immiscibility region. The polymers which are immiscible, that means 2 phases will exist below the phase transition temperature, that is called UCST. Upper CST they will exist. Below this it is existing in 2 phases, and above this it is existing in single phase. So this is about thermoresponsive polymers. What are its applications? In drug delivery systems it is having lot of applications, and then it is used to develop a drug delivery system that releases drugs at specified temperatures, like near body temperature for targeted therapy. And then polymers like poly N isopropyl acrylamide, that is PNIPAM, are popular for this, or we can say best example for this type of drug delivery systems. And then in thermal regulation fabrics also it is having applications. Thermoresponsive polymers are integrated into clothing to adjust insulation properties dynamically, providing a comfort in varying environmental conditions. So basing on seasonal changes, sometimes we have to feel, sometimes we will feel suffocation, sometimes it is like cold temperature, so accordingly it will behave. So and then it is also having applications in solar energy systems, that thermoresponsive polymers are also used like a based coatings on solar panels, which are able to regulate the thermal properties to enhance the efficiency in varying climates. So even on solar panels also we can coat this thermoresponsive polymers as a coating, so that it is able to enhance the efficiency basing on various weather conditions. And then in water purification also these were used like membranes for filtration purpose. So in membrane filters, these are able to facilitate temperature sensitive filtration, and separation process is also possible. This is able to improve the efficiency in desalination or wastewater treatment. Desalination means hard water will have lot of salt content that can be easily removed when this membranes are having this kind of thermoresponsive polymers. And even in wastewater treatment also it is having applications. So that's all for today's class. In today's class, what we have discussed is introduction to smart materials, and then 1 or 2 examples, and then what are the basic components of smart materials we discussed. After that, various categories, or we can say examples of smart materials. In today's class we discussed about 6 to 7 various categories or various examples of smart materials. So that's all for today's class. In the coming session or in the next session, we are going to learn about some examples, few examples for thermoresponsive polymers, their preparation, properties and application. So that's all for today's class. Have a nice day. Thank you.